Hello everyone, welcome to Mind Maps. In this video lecture, we are discussing Azo Dyes. We are continuing with the lecture series on dyes, and today we have many Azo dyes to discuss, as you can already see. Okay, so let's be quick. Now we start with sulfonilic acid. Okay, we are going to discuss two dyes in this slide. We'll go towards the right and downwards, and then right downwards. So this sulfonilic acid will undergo diazotization. This is 4-amino sulfonic acid, diazotization N2Cl minus, and react with N,N-dimethyl and form methyl orange. So this is the first part, sulfonilic acid, right? And this is the second part of the reactant that is added, N,N-dimethyl. So this is an indicator and it gives an orange color. Now in acidic medium we have a cunoid form and it is red in color. When you add 2-naphthol to diazotized sulfonilic acid, we get orange too. So this is the second dye. This is the first part, okay, and this is 2-naphthol. 1, 2. The substitution, okay, occurs at position number 1 of naphthol, 2-naphthol. Then we get orange too. Now we have para red. Okay, these are trivial names. We start with para-nitroaniline, then it undergoes diazotization, okay, for this thing, N double bond N, and then we have 2-naphthol. This is para red. Okay, in the previous slide we discussed orange too. It had a SO3 minus. Okay, but here we have NO2 nitro group. So this is para red. The next compound that we have is metanyl yellow. So if you can guess, this is diazotized metallinic acid, and we have diphenylamine. Okay, from the structure itself you can guess what the starting materials are, because these are all coupling reactions. We have aniline yellow. The first is diazotized aniline plus aniline. Okay, then we have butter yellow. As the name suggests, this is used for coloring butter. So we have diazotized aniline, just like aniline yellow, and we have N,N-dimethyl. Okay, so these structures are pretty much self-explanatory. Next we are discussing Congo red. Okay, this is a huge structure perhaps, but it is not as difficult as it seems. We have naphthionic acid, 4-amino naphthol sulfonic acid, something like that, naphthionic acid. And we have tetrazotized benzidine. Okay, one unit is diazo and we have 2 units, so we say tetraazo. This is benzene molecule, and we have another molecule of naphthionic acid. These can undergo coupling reaction. Okay, the substitution takes place at position number 2 on the molecules. Okay, position number 2. This N2Cl minus goes right here. HCl is eliminated. Okay, this is the central part, tetraazo, and side rings. Okay, naphthenic acid substituents. Now in alkaline, this is red. This is red in alkaline medium, and acid it turns blue. Okay, so there is some disruption in the structure. Okay, these nitrogens in the vicinity of the central part get protonated, and this gives a blue color. Okay, and this is the quinoid form. This is known as a quinoid form. Now what we have next is Bismarck brown. Okay, this is tetraazotized or amphenylene diamine, right? And using this we can form this Bismarck brown. And this is diamino, right? 1,3-diamino benzene. Okay, substitution occurs at position number 1, 2, 3, 4, 5, 6, sixth position. I don't know how we count after it is added. I guess that should be 6 only, or how we name it in IUPAC. So this is a modern dye for leather, brown dye. It is brown in color. Now the next and the last azo dye that we are discussing is Prontosil. Okay, this dye, we're not discussing the synthesis, but something nice what happened as a result of accident. So there was this German scientist, okay, Domag. Okay, this he found this dye. He tried to dye a bacteria with this. Okay, he used this dye to dye a bacteria. So what happened when he dyed this? It underwent a conversion and it formed a drug, sulfanilide anilamide. Okay, so this is how you pronounce it, sulfanilamide. Alright, so this has antibacterial properties, and he just used this drug on his own daughter, and in 1939 he was awarded the Nobel Peace Prize in Medicinal Chemistry, right? Nobel Prize in Medicine actually. So this is it for this lecture. In the next video lecture we'll discuss the remaining topics. Thank you for watching.